Let's look more at how types, inference, and notation work in Shplait. Here's a function f that takes in two arguments, x and y. We can call f with two numbers, and we could also call f with two booleans. So we can give it different types of input, but the two inputs in any call need to be the same. We can't do f of 1 and true. And that's because f uses x and y inside the two branches of an if. Typing rule for if says that both branches need to have the same type, so that puts a constraint on the types of x and y. They've got to be the same. We can write types for x and y, and we'll get the same behavior as before. If we change one of these a's to be int, though, then we get a different behavior. So now we can call f with two ints, but we can't call f with two booleans. Let's change this back. We'll do x with type a, but inside the program, we'll do x plus 1. Well, now we're back again at a restricted kind of f. We can call it with ints, but we can't call it with booleans. So at first glance, this function looks like a polymorphic function, but based on the body of the function, it's not actually polymorphic. And what this means is when we write down a type variable like alpha, it's a wildcard to be filled in sooner or later. And in this case, it gets filled in sooner because of how the function uses that value x, which has the wildcard type. For a different function, using the same or different wildcards can make a difference. So let's do a function g here. And this one takes in two arguments and returns a pair containing both of them. We can call g with two numbers or g with two booleans, but not a mix. But if we change y to have type b instead of a, then we can mix things up. Unlike with if, creating a pair doesn't put any constraints on the types that the variables have. So when we write two different wildcards, we can get two different results. And if we write the same wildcard in both positions, then we add our constraint saying that the types of those arguments need to be the same type. Let's use the different types now. So x is an a, y is a b. But on the inside, let's use x as if it's an int. What type do we get for g? So now the wildcard a for x got filled in with int, but the wildcard for b remains. We still have freedom with that. It turns out on the right that Splait's printing just starts off with a as the first type variable. So since there's no variable for the first argument to the function, a is free for the second argument. Just a minor note, that's why we have a instead of b on the right. As another example, let's rewrite this again. So x will be an a, but y will be an a arrow a function. Now the types for x and y don't need to be exactly the same, but they do need to be related. We call g, say, with a number and a function that takes in a number, but we can't call g with a boolean and a function that takes a number. That second call breaks our a constraint, but we could call g with a boolean and a function that takes in a boolean. Whoops. There we go. If we go back and change y, so instead of a to a, it's now an a to b, then we have a different sort of constraint on the two arguments. So the type for x needs to match the input type of y, but it doesn't need to match the result type. So we can call, let's see, g with 1 and a function that takes in an int and returns true. That works now, and it wouldn't have worked before. But again, this b is only a free b as long as the function doesn't use it in any certain way. If we go back to using if like we had before, so in one case we return x, and in another case we return y applied to x. Now we've suddenly put a new constraint. So using y inside that if means that the result type of y needs to match the type of x. So y has to be an a to a function. Let's now define two different functions. So f1 takes in an a and returns it, and f2 will do the same thing. These two functions have polymorphic types. They both happen to use a inside their types, but those a's are unrelated to one another. If we wrote two nested functions, though, this takes in an a and then it returns a function, which takes another a and returns it. The two a's here inside f3 need to be the same a. This second variable has to be the same thing as the first variable. We remove the type annotations, though, then there's no constraint on the inner function. And that's because there's no code using the variables x and y inside the body that puts any constraints on them. The only reason we had a constraint in the first place was because we wrote it down in the type.